Hi boys and girls, this is Ms. Hadamio, and I would like to go over the solutions for our DMA Week 1, Day 3. So let's take a look at our first problem. It says, Mandy made 27 pizzas. She made 16 pepperoni, 4 cheese pizzas, and the rest were sausage. How many sausage pizzas did Mandy make? So again, looking at our strategy of KFA, our first letter is the K, and we want to know, what do we know in this problem? So we're going to underline that information. So we know that Mandy made a total of 27 pizzas. 16 of those pizzas were pepperoni. 4 of the others were cheese. And then the rest were sausage. So next, we want to decide what it is that we're trying to solve for. So our question is, how many sausage pizzas did Mandy make? So we're going to circle that because that's what we're trying to find. So now we can take a look and decide how we are going to write a statement that helping us to figure out what our question is asking us for, to solve for. So the question is, how many sausage pizzas did Mandy make? So we are going to write an answer statement, and our answer statement should have part of our question involved. So it's going to be Mandy made blank sausage pizzas and then we can go back and we can explain our thinking once we've decided how we're going to approach this problem. So that's our answer statement, and we'll come back to that. So again, we're going to look back at our information that we know. So we know that Mandy has 27 pizzas total. So there's 27 pizzas. And of those pizzas, 16 are pepperoni. 4 of those are going to be cheese, and the rest are going to be sausage. But we don't know how many sausage pizzas we have. That's what we're trying to solve. So we know our total. We know that we have 16 pepperoni. We know that we have 4 cheese, but we're trying to find out what the rest of the pizzas are that are going to be sausage. So one way that we could think about solving for this is we take the pepperoni and the cheese pizzas that we do know and add those together to find that part of our total. And in this case, it would be 20 pepperoni and 20 cheese. Now, we need to solve for the sausage. So we can think about, okay, well, if we have 20 pepperoni and cheese, then how many more would we need that are sausage to make 27 pizzas? So thinking about how to get from 20 to 27, you could add 7 more pizzas, and you would have 27 is the same as 27, because an equal sign means equal, not answer. Remember that. Now, another way that we could look at thinking about solving this is we could take 27 total pizzas, subtract the 16 that are going to be pepperoni, subtract the 4 that are going to be cheese, and that should give us what's left of the pizzas that are going to be sausage. That's another way to think about it. So if I take 27 and I subtract 10, that would be 17. Subtract 6, that would be 11. Then if I take and subtract 4 more, 11, so I'm going to go ahead and show this work. So 27 minus 16 is going to leave me with 11. Then I take the 11 minus 4, and 11 minus 4 is going to give me 7 left over. So there's another way to solve and use your thinking for solving for how many pizzas are left that are sausage. So we can finish our answer statement. Mandy made 7 sausage pizzas because, and I'm going to use my second strategy to explain my work here. So I'm going to say Mandy made 7 sausage pizzas because 27 total pizzas minus 16 pepperoni leaves 11. Now I subtract 4 more from 11 to get 7. And there is our explanation to go with our word problem. So now I can go back to my answer here, and we can write 7 sausage pizzas. Now we're going to move on to what we have is next is rounding. So whenever we talk about rounding, we're talking about numbers that are rounded to the closest 100. Remember, we're not adding 100 because we're wanting to work with numbers that are easy to add quickly in our head. So multiples of our 100 should be easy to add quickly when we're estimating. So one of the things that we want to do is look at a number line that is broken up into hundreds. So my first section is 100. My second section has 200, 100 to 200. Then I have 200 to 300. Then I have 300 to 400. And I have 400 to 500. So let's look at our first number that we want to round. The first number that we want to round is the number 324. So if we look at our hundreds place, we see 300. And then we would know that 324 is going to fall between 300 and 400. But where is it going to be? So if we look at these blue lines as multiples of 10, this would be 310, 320, 330, 340, 350, and so on, 360, 370, 380, 390, 400. Now, where would 324 lie? Well, 310, 320, 324 would be right around here somewhere. Now, again, we don't have to be exact because we're wanting to round to see which 100 it's closest to. So it's right here between the 320 and the 330. So now we think about, okay, well, if 350 is right in the middle of our hundreds, and we're looking for the closest 100, we can see that 324 is less than 350, and we're going to round it to 300. It is closer to the 300. So now we can go to our answer document, and we could say 324 is closer or rounds to 300. So now let's I'm going to skip 558 for just a moment, and I want to think about the number 256. So again, we look at the hundreds place, 200, and the next 100 is 300. So it must be, 256 is going to lie between the 200s of 200 and 300. Now, 256, well, we know this red mark is going to be 250. The next blue line is 260. So it must be right around here somewhere at 256. So we're going to label that. And now we think, well, since it's past the middle point or past 250, which 100 is it going to be closer to? Well, remember, 200 and 250 are 50 away from each other, and 250 to 300 are also 50. So we know that since 256 is just past the 250 mark, it's going to be closer to our 300. So now we can say, back to our answer sheet, that 256 would also round to 300 because it's past 250 and it's closer. Now let's think about 558. So it's going to be between 500 and the next 100, which would be 600. And if we look at our tens, we're at 58, which means we're past the 550 mark. And since it's greater than 550, we know that we're going to be closer to 600. And again, this is just a mini lesson just to get us started. We will have a formal lesson later, but this is just something to help us get started on the idea of rounding. Now, the next has to do with our geometry. It's a geometry question, and it's asking us to color all the quadrilaterals. So we need to know a little bit about what the word quadrilateral means. So if you've ever heard of the word part quad, quad means 4, and laterals actually means sides. So when it asks us to color all the quadrilaterals, it's asking us to color all the 4-sided figures. So we know that a square has 4 sides because it's made up of 4 line segments. We also know that a rectangle is a quadrilateral because it is also made up of 4 line segments. 1, 2, 3, 4. And it also has 4 corners. And these happen to be 90-degree angle corners or right angles. And we also have another 4-sided figure. And this term may be new to you, but this is called a parallelogram. Okay, so we are also going to shade in this figure as well. Now, a triangle is only a 3-sided figure with 3 line segments and 3 angles. So since this is not a 4-sided figure, or it has 4 angles, we're going to not shade in the triangles because it doesn't match with what a quadrilateral is. The next problem we have is write the number in standard form. Standard form means we're taking each digit and we're placing it in a place that the digit has value to. So the 3 and the 30 and the 500 are all going to have a place value. So 3, we're talking about 3 ones. The 30 means 3 tens, so that digit goes in the tens place as a 33 because we put these together and that makes 33. And the 5 is 500, so it will go in the hundreds place. So basically what we're doing is we're taking the digits and placing them into their values to create a standard number. So that's it for today on week 1, day 3. We will continue our math problem solving tomorrow for day 4 on DMA. See you tomorrow.